I only have side-by-side mode and keyboard layout there.
You can just start.
Okay, so my name's Annabelle Pandaki, and I was a project manager for my team, and I got to work with Gabe, Nicole, Nick, Shruti, and Tito, and our project was on classifying tumors with a logistic regression model. And next slide. In our project, we chose to identify the top 3 indicative features of classifying benign versus malignant tumors for breast cancer.
So the way we went about with conducting the project was basically first we planned what we wanted to do. So we started by picking the model, which was logistic regression, and picking the topic, as well as gathering some data sets and other educational resources. After that, we went to the development, and we split our group into 2 subgroups where we basically did the project separately. After that, we joined our project together and made a accuracy comparison between them to find the top 3 most accurate features. And after that, we merged our code into a single Google Colab file and deployed it to GitHub Pages.
So a little bit about the model and our algorithm. So to explain the model, we have to explain the dataset first. And our dataset consisted of 13 distinct features that described each of the tumors. And one of these features actually described whether that tumor was malignant or benign. So for this, we found that a supervised learning algorithm, and more specifically, a logistic regression, would be the best algorithm for a classification problem. And it would also be the most beginner friendly. In this case, a linear regression would not have worked because what we're trying to predict, being benign versus malignant, that's not continuous or numerical. One of the problems, though, with using logistic regression is that there could be overfitting. And for this, we use cross-validation to make sure that our model does indeed work on new and unseen data.
So to complete our project, we used a wide variety of libraries. The first one we used was Pandas. For Pandas, we used it to read data from our CSV file, as well as do some manipulation to our data to prepare it for the logistic regression. We also used NumPy, which we used after we had our model in order to process the results so we could prepare them to be used for graphs. The library we used the most was scikit-learn. This is what we used to actually do the logistic regression as well as the confusion matrix. Then we also used matplotlib. So we used this to make graphs after we had all our data to visualize our results. And then finally, we used GitHub Pages in order to deploy our project so we could share it easily.
Yeah, so when it comes to demoing the project, like Nick said, we used a lot of those packages to analyze our data. And the data set contained 11 factors that contributed to cancer detection. And throughout our analysis, we determined that the top 3 were blend chromatin, cell size, and cell shape. So in this Jupyter notebook, we did the same analysis for all 11 factors, but we've shown you the analysis for the top 3 factors in this web page. And after performing the logistic regression, we found the respective accuracies. And if we scroll to the bottom, we displayed all of our results graphically at the very end. And the results that we received from this analysis showed that cell size was the most important factor to determining the occurrence of cancer. And this is in line with the literature that we see about cancer cells. And as we learn more about ML, we hope to obtain even more information about the detection.
So more than learning about the vast intricacies of cancer, we also learned some technical and soft skills. So for technical skills, as we went through the project, we learned about machine learning principles, pre-processing, visualization, and deployment. Furthermore, it was also our first times working virtually on a project together as well. We all did not know each other before, but we were still able to foster a friendly and productive environment virtually to complete our project. Through doing so, we built upon soft skills such as collaboration, time management, and problem solving.
Okay, so that kind of concludes our presentation. So if you have any questions, let us know.
Hi, I had a question about how you guys generated the models. So did you guys like uh, come up with a logistic regressor for each of the features that you guys shared in the graphs?
So yeah, there were 11 features total, and we sort of split up the work, and each of us worked on 1 or 2 features to create the logistic regression for each feature. And we just found the top 3 accurate features, which we used to conduct our subsequent analyses.
Did you guys conduct logistic regression for all of the features in the data set?
Yeah, for each one.
Oh no, not individually, like all the features
Oh, sorry.
together.
For all of them together, we did do one just to see it as a control. I think someone else could explain that better that they did. I think Gabe.
Yeah,
But
so more specifically, we got the data set and applied the logistic regression into the data set as a whole. But that turned out to be not a good, let's say, visualizing point. It didn't give us any insight on what we wanted to visualize, so we decided to go with the individual features.
Thank you.
Yeah, just adding on, I would love to just see more of the graphs. Like, could you guys expand more on the features that you found were essential?
yeah, I'll just open the file. So here we've only showed the top 3 features, which were bland chromatin, cell size, and cell shape. And sorry, just so the accuracies that we found for each one, the most accurate one was cell size, which had a 93% accuracy, after which was cell shape and bland chromatin. And this was just displayed using matplotlib. I'm sorry, I'm not sure if I answered your question.
No. That's all I wanted. I just wanted to see like the features and how you guys displayed it. So that was really well done. Thank you.
Can you guys hear me now?
Yep.
Okay, awesome, cool. Do you guys have any findings you'd say, like any conclusions that you can come to now that you've done this research project?
I would say in terms of finding, I think this research project, it wasn't so much as discovering something new because like we mentioned earlier, in terms of the results that we got, it's pretty in line with what we see like in practice. Like we know that cell size is a really important feature in determining like, you know, whether a lump is cancerous or not. But I think it just helped us to understand kind of like understand all of that from a more like statistical perspective, and just really allowed us to like gain that technical knowledge because like what we see in our results match up with what we know is out there. So I think this is like a starting point, and as we are able to like learn more, we'll be able to like come up with a lot more information about this.
Great, thanks.
Could someone talk about the data set that was used? I'm just curious where you guys got it from, how many patients. I think the only thing that was mentioned was that there's 11 features.
Yeah, so the data set, it's from like the 90s from in Wisconsin. They kept a bunch of records. And so it was, we just found it on the internet, and it had like 600 patients data in it. And then with the 11 features.
Thank you.
Judges, do you guys have any more questions? If not, we can move on. Okay. For the next group, does someone want to request remote control from me again?
Yeah, you forgot request.
Oh, I accepted your
All right,
request.
perfect. All right. Hi, everyone. So our group was doing a handwriting digit recognition project, and we're using the MNIST dataset for it.
So when we started the project, we had two main goals in mind. The first one being to develop a stronger understanding of machine learning principles and the methods used. The second one was to look into a neural network and convolutional neural network structures.
We decided to choose a project that focused more on computer vision and image recognition. So we used a convolutional neural network on the MNIST database in order to achieve identification of handwritten digits from 0 to 9.
Sorry. For this project, we have to use a couple of Python modules to build and implement the model. The most important module that we used was TensorFlow, a Python library that was created by Google, and is capable of creating a machine learning model. In addition to TensorFlow, there are a few other libraries that help us visualize and process the data and to measure the efficiency of the module. So we use NumPy, which is a math library that's optimized for Python. We also use scikit-learn to split the data into training data and testing data. And we also use matplotlib, which give us the ability to plot out data.
In terms of the actual architecture of the model and what decisions we made going into that, we went with a convolutional neural network to tackle this categorical problem. And the reason we went with the convolutional neural network is because we are analyzing not just single dimension data, and we're getting this in the form of an image. So the convolutional neural network allows us to do those convolutional functions onto it and still treat it categorically through a neural net that ends with 10 nodes, which fit our 10 categories that we can fit our digits into. So our actual structure started with a basic input layer of 28 by 28 by 1. The reason this is the shape of the input layer for our structure is because all the images came in a 28 by 28 pixel format. And then that one at the end is just the dimension for the colors. All our images came in grayscale and not RGB, so we'd only have one color channel. And that's what sort of defines the 28 by 28 by 1 shape that we needed. Then we went to two different sets of convolutional layers. Each set had two convolutional layers, which basically just work as matrix functions on a 2D array of pixel values, and that's to identify specific image structures like horizontal lines or vertical lines and things like that. Followed by these two, there was a pooling layer, and these pooling layers were basically just used to simplify the images down and would take a certain section of pixels, whether a grouping of 4, for example, and give them the same value. Then it would be a dropout layer, and the whole point of the dropout layer was to prevent overfitting. Overfitting is an issue that we did worry about early on. And mainly a dropout layer just lets us skip some nodes here or there and do recalculate weights for certain things to avoid focusing on the noise and avoid memorizing the data rather than actually learning how to interpret the data. Two of these followed by a flatten layer. The idea of a flatten layer is just to take that two-dimensional data, compress it down back into a single dimension. Then we can run it through sort of the standard neural net layers, so a hidden dense layer, followed by another dense layer which has 10 nodes specific to our 10 outputs being from 0 to 9. And before we ran it through this actual model, we had a bunch of data augmentation using the image data generator function in Keras. So we used shear, zoom, and rotation, allowing us to increase our data set, which was originally around 42,000 images. This let us increase it by a certain amount for each of the different possibilities. So shear allowed us to stretch and twist our images in a certain form. Zoom allowed us to increase and decrease the zoom rate. And then the rotation gave us, I think we used about 20 degrees rotation either way. And this is just because handwriting is very unique, so having so much variation we thought was the best possible idea. And then we have some precision, recall, and F1 scores for different categories that we have there.
So in terms of what we were able to achieve, we successfully constructed a convolutional neural network to recognize handwritten digits from 0 to 9. with a validation accuracy of roughly 98%. And then we were also able to deploy an interactive web page to demonstrate the project. And some of the things that we learned the advantage of using a validation set so that it can provide an unbiased view into the model's ability to adapt to variations in handwriting, so that the model itself doesn't just memorize the initial training set. It is more well suited to learn. And then the use of multiple layers. So for example, a dropout layer was used to reduce overfitting. And then just the importance of collaboration and coming together as a team to build like this overall final model.
So we have a demo video, so we're showing our deployment as an HTML page. And I think this link should lead us there. I hope everyone can see if it's not too small. Yeah, so that was just a basic demonstration of the deployment method we went with, which is just like a web page that was like locally hosted. Hopefully in the future we can get some sort of like public hosting and actually like let people try it out for themselves. But mainly all it really did was make a canvas HTML object, and then with some JavaScript let you draw on it. Then it would send a post request to a Flask-based server, which would then run the model and then just return whatever it believed it to be. Yeah. Thank you. That's all we have for our project.
Awesome. That's really well done. I just have one question and then a follow-up question. If I recall correctly, this is a beginner team, and I was wondering how many of you actually had prior experience with machine learning?
I was the only one coming in. I'm the PM for the group, and I was the only one coming in with prior knowledge.
Okay, that's awesome. So I just want to learn or hear more about how the team took their approach towards learning all of these materials, all of the material.
Yeah, so if one of you guys want to answer that question, because you guys, I think it'd be cooler answer from one of you, because
Yeah.
it's kind of new to you guys.
It was definitely a steep learning curve, but we did spend the first part of the semester sort of making sure to clarify everything and almost talking it out before we went into programming to understand it and understand the concepts ourselves before we just started coding things. And that made it a lot easier, especially with Daniel helping.
Yeah, no, that's awesome. Thank you.
I have a question about how you guys went about learning in terms of like resources. Because obviously you can go back to like the original papers versus taking like a Coursera course together, YouTube videos or books. Like, what did you guys prefer? And especially like as a group, what did you find most useful?
I think for me, I'm a med sci student, so I didn't have like any experience in like coding or anything at all. So I found YouTube videos to be really helpful just to be able to walk myself through it, and then going over just the theory so that it puts it like in perspective for me. So that definitely helped.
Yeah, I think to add on to that, yeah, there's definitely the two halves to it. The like theory and just understanding what the code does versus the actual implementation of it. And I think in one, like the sort of papers and things like that, those are really helpful in terms of understanding what you're doing. Then walkthroughs of simple problems and just, you know, even just step by step, like seeing other notebooks that have been posted online, things like that help you with the implementation. And then you sort of just put two and two together, and eventually it becomes more like natural to produce your own.
Awesome project, guys. Great job. I just had a question about the architecture. Did you guys try any other like different designs with like more layers, different size filters?
Yeah, so our main sort of like goal with that was everyone actually part of the learning was just to build one, regardless of whether the accuracy was good, right? And just to see if we could get one that just compiled and had a like repeatable result. So the goal was originally just for all of us to try to make one as well as we could. And then we actually ended up going with Hannah's model in the end, just because it was producing a like consistently respectable accuracy. And then from that point on, we just sort of went with that as the base, and then with tweaks and modifications. Like, if you remember, Hannah, I don't think we originally had dropout layers, but that helped a lot. So that's sort of what we sort of went off of.
It's definitely a combination of all of our model ideas put together.
Awesome. Thanks, guys.
Okay, judges, do you guys have any more questions? If not, we can move on. Okay. Next presentation. Okay.
Thanks, Sarah. Right, so my name is Kaio, and our group worked on a music genre classification project. Do I have control of the screen? Okay, I do. Right, so basically what we created is a deep learning model that classifies songs into 10 genres, so like rock, blues, classical, etc. And we were able to achieve a 68% accuracy. And we also deployed a Flask website. And now I'll pass it on to Walter to talk about our goals.
So the project goals for this assignment was basically first and foremost to learn more about AI. I came into this group not knowing anything, so it was a great introductory experience. Kyle and a couple others knew something, so they're great guidance as well. Secondly, we wish to practice teamwork. Now more than ever, it's going to be difficult working alongside new teammates, making new bonds over this virtual kind of networking. So this was a great introduction to kind of working collaboratively on projects and being able to pass everything back and forth and getting to meet new people. And finally, the last goal was to publish a Flask website, and that actually lets people use the model so we could actually have something tangible coming out of this assignment. Next slide, please.
So some of the technologies we used, obviously they've been discussed: TensorFlow, Keras, scikit-learn. Flask was used for our front end, but a lot of people might not know we used Librosa, and so Librosa is actually a library for reading and manipulating audio data. So we didn't actually have like a pre-filled CSV file with all of our data. We actually created our own data using Librosa. So we downloaded 1,000 songs with 100 songs from each genre, and actually used Librosa to extract features from each of the audio files into a CSV. And so we ended up with 20 different features for each audio file pretty much. And so some would be the spectral centroid, which would be kind of the mass of the audio file weight, or the zero crossing rate, which would be the rate of signal changes within the audio. And so there's 20 different features for each file. And that helped us create our model. And I'll pass it back to Walter. He'll talk more about the model that we used from that data.
Yeah, so once we were actually able to develop our data set, we had to iterate through a bunch of models. The tutorial that we followed uses a k-nearest neighbor model. We implemented that ourselves, and we were only actually able to achieve an accuracy of 54%. So then we decided to try out an artificial neural network. We tried the first one with one layer, and we're able to get much higher accuracy of 64%. We then tried one with 2 layers and had to iterate through a couple parameters, affect the learning rate, etc. And we're actually able to get a percentage, an accuracy percentage of 68%. So using that, we were then able to take that model and deploy it on a Flask website, which Kyle will talk more about now.
Yeah, so if anyone wants to access it, this is the link. It's a bit long, so apologies for that, but it looks like this. Now let's see if we can do a demo.
Sorry, I have the file actually uploaded.
Okay.
So I'm gonna click on the link for you guys, and it's
Yeah, that one. So that's a classical song, and if anyone wants to listen to it, it basically sounds like this. So it is an actual song. We're not just pretending. But yeah, so you can upload your file, and once you press upload, did that go through? There you go. So basically that goes to our Flask server, and it calculates all the features that Ben talked about. And it returns those features to the front end, which it uses TensorFlow.js to actually run the model on your browser just to make it faster. And it calculates the genre based on that. So there's like different sample files here if someone wants to try them out. But basically you just come here and you upload your file, and it tells you what genre it is. And yeah, so now back to presentation, and now Ben's going to talk about the learning outcomes.
Yeah, so obviously some of the learning outcomes as like an intermediate team was we wanted to get more into the algorithms behind like neural networks and the different types that we could use. So we obviously explored with some different ones and found you know, some were better than others. And then obviously working virtually, we wanted to ensure that we were working together as a team. So we would set consistent milestones, make sure we had consistent meetings, and we even had a McCabe's night as a team, you know, to bond and to work better and to learn basically from each other. It's all a learning experience. So we had fun, made new friends, and learned more about AI and different networks and technologies.
For sure. Yeah, and just before we finish off, just want to say thanks to our fourth team member, Renee. He wasn't able to be here, but he really helped us. And now if anyone has any questions.
Yeah, I'm just really curious about all your features. If you guys can go over them or show like how you extracted them.
Yeah, sure. I guess I have my Python file here. So basically,
even just like a quick listing or
for
like
sure, yeah.
the coolest one you found or whatever.
So we would go through, you know, obviously all the audio files, and so we would get 0 crossing rate, which would be the rate of signal change. And so you could see that, like, obviously, like within like a classical song, that signal changes for a classical song, the coefficient would be very low because it's consistently like the same, like quiet, like Kyle was just playing the song there. But if you got into more EDM song, where there's like bass drops and stuff, obviously that rate throughout the whole song would just be very high because it would be constantly building up, dropping, going up and down. And so that was one of the main, like a main feature that you would see is different between the different genres. And then a key one as well was called the Mel frequency cepstral coefficients. And so that basically is run on all the segments of each song, and it extracts basically how many frames within this song are like varied. And so there would be, you know, for each second of the song, it would change the coefficient and it would kind of average it out. So I guess that was like some of the features that we would like extract from the song.
Yeah.
Awesome.
Could you guys explain briefly like the design of the neural net that you guys use? Was it like a recurrent neural net like over the song, or was it that you guys just extracted the features and it's like a one shot, just it's like it's multi-layer?
Right, so we tried a few different options, but at the end what we had was basically a Python notebook that first pre-processed data, and then it went through the model. And if I can remember, the model was relatively simple. It was mostly just your regular like hidden layers and dropout layers, not a recurrent model. So like just a regular artificial neural network model, and that worked best for us.
Cool, thank you.
Yeah, I just have one question. Like you guys mentioned that you guys are not using a CSV file as your data set, and you guys are actually like downloading all the musics from online. So I was just curious, like, did you find the data set, like the library of music online, or did you guys like manually download all the music? Like how did
Yeah,
you manage that? Oh,
we found a file that just had there's 1,000 different songs, all classified with each different genre labeled all nicely, and so we were able to just to run that. They weren't like full, 3-minute songs. They were basically smaller segments, but because there's 100 different ones for each genre, it would encompass all parts of different songs for each genre.
Yeah, and just to be clear, we did end up with a CSV to like train the model, but that CSV was created from the actual songs.
awesome.
Guys, I have a quick question for you. Thanks also to everyone for coming. I appreciate it. So I was actually wondering if you guys knew each other before the project or how you kind of came together as a group.
Yeah, so no, we did not, but
No.
we basically just all entered the same team and we became friends. Yeah.
Yeah. I'll give them
so you
one up to Kyle. Sorry, I just wanted to say, like, he did a really good job managing us being a PM. Like, he
Yeah.
organized the
Kyle
McCabe's
was a
night and
great PM.
everything. He was on it every week with a weekly meeting, so he was a big part in that.
So you guys just applied then to the project and then kind of got lucky with your placement.
Yeah, honestly, we didn't know each other at all, and we just happened to become a team. So
Interesting. Thank you.
Okay, next we have COVID-19 predictor.
My name is Nelvin, and I'm the project manager for the intermediate team. My group members are Octavio, Alexi, Hamzayan, Rithik, and Abbas. All of them here today except for unfortunately Alexi. We'll be giving a presentation for what we built. So an overview of our project. So basically, we created a website where it allows the user to upload a picture of an X-ray of their lungs, and it classifies whether the user has tested positive or negative for COVID-19. So our problem was basically we used image classification, and it was supervised learning because the data set we found one on Kaggle. It was called the COVID-19 radiography database. So there was 2 folders in that data set, one called COVID-19 and one called normal. So basically all the images in the COVID-19 folder were all classified as COVID-19, and then the normal folder was all classified as normal. So basically that's what we went with for our project. We classified as either one of the 2 classes. And I'll let my other teammates take over the ML code part.
Yeah, so as Nelvin mentioned, we used CNNs and specifically technologies like TensorFlow to do this image classifications. Just a brief overview on what CNNs are. CNNs are used in image recognition and for self-driving vehicles and essentially creating a multi-layered neural network. So with regards to image classification, each images are made up of pixels, and each pixel can be represented by a number. So we can have digital representation of those images. So after importing the necessary libraries, we used the sequential model to create the stack of layers and applied the, just to initialize the neural network. Then we applied the rectified linear unit on the neural network. And we had to implement pooling, which essentially enables the network to detect features in various images irrespective of the difference in lighting in the pictures. We did flattening, which transformed the entire pooled feature map matrix into a single column to feed to the neural network for processing. Then we have like dense, which essentially adds the fully connected layer to the neural network. And we had to implement the dropout function just to prevent overfitting and to increase accuracy. I think Hamzayan can take over for the rest of the half.
So adding on to a boss, so using that data, we use the Atom optimization algorithm in order to like determine whether or not the images have COVID. Now we split the data, and so to set up the accuracy for it, we had a validation set, and this validation set was kept separate from the actual data set to test how accurate our data was when we were predicting if the lungs have COVID. As you can see, if you scroll down a bit, you could see the iterations that we used testing different lung images. And it ended up being, the training accuracy was 97%. And then when we used our validation set, comparing it with the training accuracy, it was 96.2%. Yeah, that's pretty much it.
Yeah, and we also were able to export to an H5 file. So because we were able to export to an H5 file, we were able to use it for our web application. So I'm going to let my my other group members.
So for creating a web app, we used a Flask web app framework to connect the ML to the front end to display the result. And then we used the Google App Engine to deploy the web app.
I have the file for this one as well, so I'm just gonna upload it.
So yeah, if you click on the predict result, it'll classify it. And if you scroll down, I should give it a few seconds. Their test result was negative. And then if you try the, this is for the normal image. Sometimes the user has not tested positive for COVID-19. Then if you try the other image, that's COVID-19. And then we click predict result again. And then yes, the user has tested positive for COVID.
I'm sorry, could you guys hear what I said? I think I was muted.
I think we heard you, yeah.
Yeah, so the website uses Bootstrap, JavaScript, CSS, and it connects, the JavaScript is used to connect the website to the machine code in the backend. Octavio can explain that more.
Yeah, so basically we use JavaScript to pass the image as a base64 to our main.py file, which uses the Flask web framework to deploy a server. And then we use a Google App Engine to deploy it permanently.
So yeah, so basically the project, we started off with determining what our idea was, and we decided we want to do like a COVID-19 predictor, and then we moved on to figuring out a data set to see if this idea was doable, and we found that the data set on Kaggle, and then we split the tasks up between we had like a web dev team, and then we had like an ML team, and we all got turns working on each part of the team, just trying to learn as much as we can. And so yeah, we pretty much merged all of like what we did. Like each person had different responsibilities. When we put together the work we all individually did, this was the final product that we came up with. So yeah, that's it for our presentation. We're now open to like answering any questions you guys have.
Yeah, thank you. That was a really good presentation. I have two questions actually, and my first question is, can you guys expand more on the learning process you all had?
Yeah, for sure. So I'll start with talk about myself with the learning process. So for me, this is we first tried. So I mostly did like parts of the ML. So what we first had trouble with was learning how to use Colab because that was like a new editor for me, and it was kind of annoying because like it always like deletes your files after you exit off. So that was something I had trouble with. And then the next thing we did was try to figure out which technology we use. Since we're doing an image classification problem, we figured that TensorFlow was obviously the way to go, and in the end, TensorFlow was really what we basically needed because we were trying to classify 2 classes, and yeah, so basically it was a lot of research on what image classification was and what supervised learning was, and that's what we used to build the code. And then for me, I also helped out with the web dev team, and we originally tried to use Heroku. We had a lot of trouble with that, with uploading it. And in the end, when we almost got it upload, we figured we were over the limit for the size limit. So then we had to switch to Google App Engine. So yeah, that's personally for me what I learned. I want to hand it off to my teammates so they can talk about what they learned. Does Octavia want to go first?
Yeah, I mostly learned from the documents provided by Western AI. That was super helpful for me. And additionally to that, I also used a lot of YouTube videos and then consulted other people that had done projects similar to me before, like had done projects with the Flask web framework. And so that was very helpful.
Yeah, I found W3 schools to be really helpful for all the Bootstrap, HTML, and CSS stuff.
Yeah, for me, it was the first time that I actually found out about Kaggle. I didn't know that there was available data like that, and it actually showed like a walkthrough on how to use that data, which was pretty useful. I guess it expanded on how many projects that I can actually do now, and the available data that's online now.
Yeah, and
Alice?
I use
sorry, you can go.
I use the resources the Western AI provided. Also use CentDex on YouTube. It's pretty good. I ran the dog versus class classification as for practice and gave me familiarity with CNNs and TensorFlow, which then I was able to utilize in the machine learning aspect to it. And obviously, thank you to Western AI for the great resources they provided. Shout out to Sajin for letting me join the club. Best decision ever.
That's really good to hear. Okay, and now my second question is, did you guys find any features that stood out that helped you identify that, oh, that image has COVID-19?
So I think it was, so I found when I was looking at the COVID-19 x-rays and both the normal x-rays, they look kind of like drastically different at times because like the lungs look, it was like different shapes. It looked kind of weird sometimes. I think basically since it was black and white images, I think we just found that like little features inside like the bone system of the lungs was what basically changed whether it was like COVID-19 or not.
I have a quick question kind of following up on that. Do you guys think that you would have benefited from like domain experts, like in your case, medical students, assuming that it's like a medical imaging? Like, do you think you could have used people who are studying in that field to help with the project in any way?
Yeah, for sure. So right now, because what our project does, it classifies only whether it's COVID-19 or normal. But what we also found is that we also tested images like users that have like lung cancer, and it still classifies COVID-19. But that might not be the case. Like someone that has lung cancer might not have COVID-19. But because an X-ray with lung cancer is clearly not normal, it's just going to obviously classify as COVID-19 instead of what it should really be classified as. So definitely, I think having medical students would be definitely beneficial.
So I think it's always important to like reflect on what our model is actually learning, right? So do you think that after you guys have like played with this data so much that you guys can identify the difference between like a normal healthy lung and a COVID-19 affected lung?
Just by looking at it?
Yeah.
I don't know if we could do that easily. It's kind of hard to do because I was trying to do that myself, kind of just for fun,
Mhm.
and it's just like it's kind of difficult because like yeah.
So did you find that the fact that you can't really, it's hard to evaluate what the CNN is actually doing inside? Was that a difficulty for you guys at any point?
Yeah, because that's what we're basically doing. We're using a convolutional neural network. Ours was sequential, so it was like linear stack of layers.
Mhm.
So yeah, it was kind of hard to picture what it was like doing inside.
Okay, cool.
Yeah, I actually had a question about the model. It seemed like you guys had just about like 4 layers. So I was wondering if you could explain like how you guys arrived to that design. Um, and what are the sizes of the input images, the X-rays?
So the size of the input, it was basically the width and height were pretty much the same. So most of them were 256 by 256, and then we had some that was 1024 by 1024. We resized them to 64 by 64. So basically, and that's one thing we specified on our website, to upload an image that's an 1-to-1 aspect ratio. And if if you want to explain our layer 4, if that's possible.
Well, we did use 4 layers, but by putting in the data sets, like we had like a lot of images. By training it for that amount of images, it seemed to give us the correct result for like when we tested it. So it seemed to fulfill the goals of the learning objectives of the project.
Cool, thank you.
Brandon, I think I gave you access to control. Is there anybody else from this team who can
Oh wait,
request
hold on.
Oh.
Hello, can you hear me?
Yeah, now I can.
Okay, yeah, sorry, I tried to get my video up before I, I started the whole remote control thing.
Okay, no worries.
Okay, guys. So my name is Brandon. I'm my team. We did the music genre classification genre, and so I just want to make sure that I can see. Is there any way that I can just see my face? Wait, so you can see my face?
Yeah, we can.
Okay, perfect. Thanks. Okay, yeah. So my team is so I'm the project manager. So my team consists of Arsh Lalani, Zain Shad, Jasdeep Singh, Fairs Nassar, and Nathan Pogue. And I'm the project manager of the team. But today it'll just be me presenting. So okay, so basically, like our goal was to build a machine learning model that uses that was able to classify music clips into their appropriate genres. So genres such as blues, classical, metal, reggae, and we basically and our project basically uses a convolutional neural network to do the music genre classification, and we used a lot of technologies such as TensorFlow and Keras, NumPy, a tool called Labrosa, which was used for to analyze the audio data, as well as scikit-learn and matplotlib. And so, okay, and so basically like from this experience, we basically like learned a lot about like how to process and manipulate audio data and all the features of audio data such as frequency, how to like analyze frequency, time, as well as how to create like spectrograms as well. And we also learned how to like solve for overfitting of data. So which is basically when like, so in a machine learning model, you have training data and testing data, and overfitting is just when our machine learning model becomes too familiar with the training data that it can't make like make any inferences or classification for new data in the real world that it hasn't seen before. And so we were, and like learning how to solve for that was a really good learning experience. Okay, so this is our video, right? So I basically did a video demonstration right here. So basically, just some background, unfortunately we didn't implement it into a web application or anything like that. We just have a working machine learning model on Google Colab. So like this is just a video of me demonstrating it right here. Hold on a second. Can you guys hear it?
No, I can't.
I think you have to share your audio as well as your screen.
Oh, wait, sorry. Can you hear it?
I can hear it, but I think it's because I'm the one sharing my screen. Oh, sorry, in the screen share option, can you like choose share audio as well?
It should be like a checkbox when you share the screen.
Yeah. Hold on, let me stop share.
Like when you share a screen in the bottom left or something, there should be a checkbox.
I don't think I have that. I think it's just like, is it in advanced sharing options? Because I have that, but hold on. No, it's like at the bottom left, it has a share sound button. Okay, I think I got it.
On to our project.
Can you guys hear it now?
Yeah, I can hear it.
Okay.
Perfect. Thanks. Video. So on the Western AI Club. So my project team is basically so my project team was working on a piece of artificial intelligence that does music classification. And so in our project, unfortunately, we didn't have enough have enough time and weren't able to implement it into a nice web or mobile application. So what we have right here is just our machine learning model right here on Google Colab. And it's already been trained and everything. And so basically, we basically implemented a convolutional neural network on our model. And so basically, and I'm just gonna like provide just a quick overview of what each piece of code does. So this piece of code right here is meant to import all of our information from Google Drive, from Google Drives, and that includes the data that we'll use to train our model and to test it and so on. This block right here is mainly meant to pre-process the data as is to mainly like pre-process the audio data, so just to break it down, create all the right graphs, and to then also to save all that data in a file called data.json, which will and it's mainly to help like actually like help train the model. This piece of this piece of code right here is just something that we use to it's just something that we use to evaluate the test accuracy and the accuracy on the testing data and the accuracy on the training data. It's just a tool that we use to solve for overfitting issues that arise in the building of our model. And so basically yeah, so right here is where we implemented the convolutional neural network right here, and also fitted it and trained it and everything. These are the results right here, and we managed to get an accuracy of like 76%, and this is on like the new testing data that our model has not seen before. And so basically, I'm just going to show you. So right here, we basically like split our data into training and testing data, and so our model right here, it's of course seen the training data and has trained itself on that, but it has not seen the testing data yet. And so basically, I'm just going to show you right here. So this is where we select a test sample from our data, and so. So basically what this means is, so X here is meant to be like a sample media clip that we select from our data, and Y here is meant to be the expected index, or like it's supposed to be the expected genre of that music clip. And so this is just this chunk of code right here is mainly used to compare the value that our model predicts to the value that it's supposed to be. So let's say let's say we select the X and Y at index 1 right here. So and then we'll try and like run this block of code to predict it. So the expected is blues, and our model predicts that it's blues, so that's good. Let's try 50. Index 50. The expected is hip hop, and our model predicts hip hop, so that's good too. Let's try one more. So our expected index is metal, and our model predicted metal, so that's good too. Let's just try just a random number. So our expected index is hip hop, and our model predicted hip hop, so it seems really good so far. So okay, yeah, so I kind of like wish I had, so yeah, for it, I wish I actually like had like a model so that you can actually like more so like see it in action, but this is kind of like what we came to so far. So yeah, so like that's pretty much that's pretty much it for the presentation. I'm open to questions right now.
Was this project based off anything? Because I thought it was cool how you guys used the MFCC and then fed it into the convolutional neural network. But did you guys like, was this based off some other kind of research or other kind of findings that you learned about?
Yeah, so I had to basically had to do a lot of research, but just on like just understanding like audio data, just understanding audio data itself, and just how to like properly like analyze all the data and everything, and how to quantify all the features. So we went on various resources, such as I guess a YouTube, Coursera, a bit of like from like a site called Udacity, and so we just had to like I tried to like learn how to kind of like combine all of them in order to like build this to build and train this neural network.
Nice.
Hi, Brandon. Great presentation. I was just wondering if you could talk about the model a little bit. I thought it was interesting how you guys use the CNN to actually analyze the audio itself.
Okay, so in order to like talk more about the model, so actually I'm actually probably gonna like share my gonna share. Is there any way I can share my screen? So I'm just gonna share my screen right now, just so that you can see my screen right now. Can you guys see my screen?
Yeah, we can.
Yep.
Okay, so just gonna go to my Google Colab. Yeah, so like basically like right here is basically like what our input layer where we just flatten all the features and everything. And here in this neural network, basically like I said earlier, to solve for overfitting, we basically implemented something called regularizers, which is basically, so let's say you have like a neural network where you have like your like your input layer, all your middle layers, and your output layer. So regularizer is just meant to help to decrease the magnitude of some of the weights. And here we also implemented another overfitting management technique called dropout, in which we basically just drop out like random neurons in the neural network in order to solve for the overfitting. And here's where we have like our output layer. So it's basically like just 10, which basically like represents our 10 different genres. So basically like what'll happen at the output layer is so the value of each output layer will like depend on like how likely the music clip fits into the genre. So for example, one output neuron, like which represents like rock, is on like 0.1, and another output layer will represent a metal, which is like 0.3. So meaning it's a little more likely that it's metal compared to if it's like rock, basically. So yeah. Okay, so I'm gonna stop sharing my screen now. Okay, so yeah.
Thank you.
We want to our.
Okay, so moving on to the next presentation.
Hey, can everyone hear me? I just want to make sure. I'm using new headphones, so I guess, yeah, just making sure. Please let me know.
Yeah, you're good.
I guess, yeah. Hey, everybody. My video's off right now, but I guess you'll see me very soon. I actually had my webcam used elsewhere, but anyways, I guess just a quick intro. My name is Jasper, and I'm the PM for this semester's Gideon teams. Today, I'm joined by my team members Zaid and Sadiq. And I guess, yeah, without further ado, I'd love to hand it over to Zaid to kind of give you guys a summary as to what our project was about.
Do you have control? Sorry.
Oh, I'm sorry.
Let's go for the next slide.
Oh yeah, perfect. Am I able to click it?
Oh, yeah, it's good now. Okay, so for the goal for our team, we wanted to kind of focus on COVID-19, because not every single day we're really faced with a pandemic. So our goal was to kind of contribute to the fight against the virus. So we made a project that detects mask in hopes to support and motivate the use of the personal protective equipments. So for the summary, the artificial intelligence program, it aims to detect whether the user, either in a photo or a live video, is wearing a mask properly. And we used a convolutional neural network to detect it through either separating the two options of either wearing a mask or not wearing a mask. And I'll pass it on to Sadiq to explain more.
Yeah, so for the technologies used for our project, we first off use like Google Colab to kind of like write out our code and build our project. And then we also use NumPy. So these kind of ones we've already kind of gone over, but like NumPy for the pre-processing and handling of our data. So in our case, our data was images, which we got from Kaggle, and it has about, the data set has about 12,000 images. And for us, luckily, the data set was already split into the training, testing, and validation sets. So that made it easier for us when we were trying to classify them um, and kind of split them up for our project. Next, we kind of use matplotlib for the visualization of our data. So usually it's used for like plotting, but in this case, we could use it to like show our images as well. So that was useful in like trying to understand if it classified something, and we could actually like see the image and we could see if our model was classifying it correctly. Next, we use Keras to build and train our convolutional neural network. So our neural network had about 11 layers, and yeah. And then lastly, we used OpenCV, which, if you guys know, is like a library which is used for implementing real-time, like real-time video. And just Preet's going to show that in a little bit. But yeah, next slide, please.
So I think I lost remote control. If you don't mind hitting that, please. Oh, perfect. Sorry, yeah. Okay. I think honestly, the biggest takeaway that I guess speaking on behalf of my entire team was, one, of course, we delivered what we wanted to do within the deadline. But I think what really made this experience unique was we kind of learned how to learn, if that makes sense. Our predominant focus wasn't necessarily, in a short amount of time, can we become experts on AI or just neural networks in general. It was more so that, given the constraints, given the requirements for a project, are we able to kind of be resourceful and learn everything required in a short amount of time? And along with that, of course, we get an experience with what our project entailed. Of course, we learned about neural networks, we learned about what OpenCV is and how to use it. And I think just overall, just the aspect of learning about end-to-end development as a team was really cool. So it was great that we got to see that. In terms of takeaways and just accomplishments of not only our model, but of our whole experience, we're actually able to deliver a project that we set out on completing. It was really cool, I think, to actually pitch the idea that we did amongst our team. It was not really a traditional project that we wanted to do. We wanted to do something that was really practical, and I think that really made it engaging for everyone. And not only that, but we created a model that was not only able to receive images as input, but also with OpenCV. It made it cool that we can implement real-time video. And in the end, we actually created a model that had an accuracy of 98.3%. And this is specifically for when images are input into the model. I think it would be really cool for us to demonstrate this. So I think if I can please request to share my own screen, that's okay. I'd love to show you guys how it works. Can I go ahead and do that now, if that's okay?
Yeah, go for it.
Sorry, just one sec. Are you able to see me? Are you guys able to see me okay?
Yeah, you can see you.
Yep.
Sure, I guess so. Yeah, so here I am. This is just a collab file, and it shows through OpenCV, I'm able to access our webcam. And of course, without wearing a mask, it's identifying me as maskless. I actually have a mask handy to show you guys, but I think one problem that we encountered just now was the lighting. So it's really dependent on the lighting that you're in. So of course, now it's showing that I'm masked. Anyways, to show you guys how it works, if given a mask, I can simply put it on like this, and it correctly identifies me as masked. So again, it depends on the lighting really, which is something that's really limiting us. But yeah, in this case, for example, it would show that it's masked. I don't know why it chose not to work now, but yeah, for example, it would show us that I'm wearing a mask now, and when I take it off, again, it's maskless. The reason there's a little bit of a delay is because our model is actually receiving input as still images, and what a video really is just a series of snapshots. Um, yeah, so that's essentially how our model works at a high level. If you guys have any questions, I'd be open to answering those as well.
Hey, yeah, I love the live demo. It's really cool. I was wondering how you guys acquire the data set. Did you guys like take pictures of it on your own, or was it like a whole data set of things? I'm assuming that affected the lighting and such.
I guess, Sadiq, if you want to answer that, otherwise I'd be happy to take it myself.
Yeah, sure. So we luckily, we found the photos online. So we just got it off of Kaggle. The data set is basically just a collection of, they look like honestly just images from the internet of like various like people with masks and without masks on. So we didn't take the pictures ourselves. They were kind of compiled for us. But yeah.
I think what was also really cool, sorry, just to add on, the data set we found was already pre-divided. So we actually had a training set and a validation set already kind of laid out for us. We were actually able to see an input of, I think it was roughly 12,000 images. So it was really good to see that variation. The one thing I will say though, the data set wasn't really consistent. There were some images that were rotated in a weird way and all sized differently. So one thing that we did have to do to pre-process this data was to resize the images to ensure just consistency. And yeah, overall, I think it was really convenient that we used Kaggle.
Thank you.
No worries.
I'm not sure if I missed it. Can you guys go into your architecture again? And also, I'm wondering did you split the face recognition and the classification separately, or is that all one model end-to-end?
Oh yeah, for sure. I actually wouldn't be able to go as in-depth as I would like, just because I think the person that worked on it in our group who will be able to provide, I guess, a better summary of it isn't actually here. But essentially our approach to this sort of building this model was, of course, collecting the data. And of course, the data would have to have associated labels. And then, so this is where the first model came in, which was just a CNN with 11 layers. And this was strictly responsible for, hey, given an image, can I correctly classify it as wearing a mask or not wearing a mask? And then this is the model that we actually trained and we had to validate on its own. And then upon doing that we kind of branched off and decided to implement the real-time video. So I guess in effect, the real-time video wasn't a separate model per se. It was almost like an extension, I guess, if that makes sense.
But I mean, the model itself is only taking the cropped face as an input, I assume?
Yeah, I guess, yeah, so if you remember the video that I was showing, or the demo, there was actually a square on my face.
Yeah.
Or I guess, I don't know if it looked more like a rectangle, but it was essentially supposed to be a 100 by 100 square set of pixels. And then so the model would just be receiving that on its own as an input. And so the way we trained it was specifically on still images. And then what OpenCV let us do was take a video, almost treat it as a sequence of still images, and just continuously feeding that to our model and determining if the person was wearing a mask or not.
Awesome, that's great.
Thank you. I guess if that's it, I'd be happy to hand that over to the next group. Or unless anyone, of course, has any more questions.
Yeah, so we're actually going to move on to our Kahoot now. I'm going to hand it off to Yasin, who's going to lead the Kahoot.
Hello, everybody. Oh, this camera's way too high. Hello. Good job, everyone. I'm just going to share my screen now. We're going to start the Kahoot. Hopefully this is fun. Which one am I sharing? Oh, man. Okay, sweet. Can you guys see the Kahoot? Awesome.
Also, the winner of the Kahoot gets a gift card to anywhere of their choice. But yeah, something to add.
Hi, before you guys hop into the Kahoot, my group and I are all here, and we thought we were gonna present as well. Maybe we didn't make it into the. I'm not really sure. We're all kind of confused right now because we submitted our project as well.
Do you guys have a slide deck ready? We can hear you guys present first before moving on to the Kahoot.
Yeah, sure. I can share my screen. All right. So yeah, we predicted. We did a really beginner project with linear regression, just predicting housing prices.
Yeah, so just a quick overview for us and beginning this project. Our timeline kind of started in September when we all got together. Our objectives was to, code as a team, get some practice using Python, and, kind of figure out what this whole AI thing was about because it sounded pretty cool. Our biggest challenge going in that we thought of was just kind of our busy schedules, all being students, and this could create like timing issues, and we all thought this would be kind of the biggest threat for us working together.
So yeah, a little background. So our group had 5 members. We're all a second-year software, and we'd never coded before using Python. I had a little bit, but not enough to really call myself experienced. We were also new to GitHub and programming as a team, so it was really cool to get an experience with commits and pull requests and understanding how that all works. So yeah, we all had a basic understanding of OOP and stuff, and we wanted to just really get a basic understanding of AI.
So as for like management within the team, we hadn't really used GitHub in any of our classes yet, so it was kind of an obvious choice considering like it's a popular workplace tool once you get out into being a real software engineer. And then as for our roles, it was like egoless, so we just bounced ideas off of each other. Nobody really controlled it in one direction. It was kind of easy to coordinate because we're in a small group and talking to each other a lot. So, yeah.
A little bit getting used to Python. Obviously, the syntax was like a little hurdle, but it's a really easily written language, and they say it's easier than Java, so we were excited getting used to that. There was a noticeable difference with arrays and just getting used to like data frames and how series work out. And the for loops are a little different as well. The libraries we used were pandas. We played around a bit with NumPy, and obviously for linear regression we used scikit-learn. They were all really powerful, and it just goes to show like what some libraries downloaded off the internet can help you with in projects.
Yeah, so kind of getting into the project, you guys probably already know this, but we learned this pretty quickly that the biggest part of machine learning is the data. So a big portion of our time was spent getting good at data cleaning, processing, all of that. So we kind of had to go through all the data. We got it from Kaggle. So we had about 80 features and I think it was 1,500 kind of different labels with the features. So we kind of had to like look over the description and figure out how to sift through the data, find biases and things like that. Another hurdle for us to get over was translating all the features into numeric values for the linear regression. The label encoder was especially useful as that kind of automated the process for us. And just for simplicity, we stuck with the linear regression model. We played around with a bit more of like the fundamental learning algorithms like KNN and decision trees, but we kind of landed on linear regression. Also, just to kind of keep this beginner, we kind of steered away from neural networks. We looked into them, but we kind of want to keep this basic for our learning purposes.
So yeah, for our schedule, so we started off in September talking about a topic, and at first we're talking about maybe doing something that could predict stock prices, but we decided that we wanted to really get a fundamental understanding of Python and using scikit-learn and stuff like that before we advanced onto more a little more complex stuff. So we explored different models to use, and we landed on linear regression, and we started using some of the free educationals from Coursera machine learning to start to get a grasp of how this really works. In December, we had our first draft, and we started to start sending commits onto our GitHub and really start working towards a final draft. And then in January, we reviewed our project goals and saw how we did.
So in the end, how did our model do? So we had a R-score average of 0.77, which is pretty good. Nothing to really call home about, but we learned a lot. We wouldn't necessarily use it in a commercial setting, but yeah, we were pretty happy with the 0.77 R-score.
Yeah, so just a look at our code here. It really wasn't a lot of code to go into it. Most of it was just loading CSV files, cleaning the data, creating the model, and then in our last method here, we ran our model 100 times and took an average R-score of each one of those just to get a real idea of how well our model was predicting. And with 0.77, it predicts the price within around $10,000 or so, up or down, so it's actually not too bad.
Yeah, so this is kind of the output of our final code here. We have kind of a number of errors there, and we noticed that it would, like 1 in 100 times, the R value would actually come out negative, like it come out like negative 0.2, which didn't make too much sense because it's kind of a sum of squared values. So that was kind of a nice question for us to try and figure out. Kind of what we went with is just kind of to keep track of it. Here you can see it didn't come up at all through the 100 models we ran. So again, like not a super common thing, but it was there. And yeah, like our average R value there displayed was 0.78. And the runtime for loading the data and then running the model 100 so times was about 50 seconds. So pretty quick learning time.
So in review for our project, so yes, we did have some errors for our first try. So it would be really cool if we, in our extra time, to go back and really see what's causing these negative R scores, because we really couldn't figure out, and we didn't have enough time to really dive into it. So yeah, so our average R scores, it was towards the end that we decided to use a loop to run it 100 times and take an average so that we were more confident with our predictions. And yeah, for next time, we want to look into convoluted neural networks and progress past the linear regression model and get that R score up.
Yeah, guys, so we'll open the floor to questions now.
Yeah, sorry, I was just thinking of something to ask, but did you guys consider deploying it to, you know, a web app or scaling it up?
Yeah, we were looking into that, but I was just looking around on not Django, the name's not coming to me, Flask, trying to develop a web app, but we figured it was so fundamental that there wasn't really to it. But next semester we're planning to do another one of these projects and we want to make it full scale.
Okay, awesome. And also, second question is, you guys said that you were all pretty much beginners and were learning this from scratch. And I was wondering, you know, what kind of process did you guys take towards learning all of this material? Like, oh, did you watch a lot of YouTube videos, or were you mostly reading it? Did you guys learn together or individually?
Yeah, like from what I said, we used some of the free educationals offered by some online sites like Coursera, and even like sending those tools between each other. So if one of us found a cool YouTube video, you know, we'd share that. And I love using YouTube to learn from tutorials and stuff. But yeah, it was just helping each other.
Yeah.
Awesome. Thank you so much.
On our own, and we just get together at the end. And I'll let us carry on with Kahoot.
Yeah, so the judges need a bit more time. In the meantime, Jessica, do you want to talk about the new Gideon apps for this semester?
Yeah, sure, I can. And if Kate wants to jump in, she can as well. So we've released the project managers and the general member applications for next semester, well, this semester's Gideon stream. So this time we only have general and specialized streams. We got rid of the 3 different levels because we thought it would be more simpler to have 2. As this past semester, we realized that a lot of the beginner people wanted to try intermediate things and overlaps in between the streams, so we decided to make it into only 2 streams. So the PM applications are closed and we've received all of them, are going through them, and the general member applications are still open. So if any of you guys who presented today are still interested in being part of the program for this semester, then by all means, please apply, and I'll link the form in the chat. And Kate, do you have anything you want to add?
Yeah, so general application will be due, I think, this Friday at 11:59 p.m. EST. So yeah, apply, guys.
And if anybody else has any questions, then feel free to reach out to me or Kate or William or Sophia on Discord or emails.
If you guys could maybe send the link to the applications in the chat, that would be great. And sorry, Spencer.
No worries. I just wanted to jump in and thank everyone for coming and participating. This is Western AI's inaugural project showcase. So I think it was run really well, first of all. So thank you to Sarah for putting on a great event and everyone who helped. And obviously all the teams that did the extra work to make a presentation and present. That's, I really appreciate that. And I think everyone here learned a bit about what everyone else was working on. And I thought the projects were super cool. So well done, everyone. Maybe to the project directors, what's the plan for project topics this semester? Are we gonna try some new ones or allow people to pick, or what's that gonna look like?
We usually let the groups talk on their own and pick. If they really don't have an idea, we can give them ideas from online or on YouTube. But in the past, we've found that most of the teams, after talking to one another, they find similar interests. So I know that Annabelle's group, her group had a lot of medical students and they really wanted to do the cancer option. So that's what they went with. And this semester, we don't know yet. We're hoping that the project teams that are assembled in the end have some of their own inspirations and passions, but if they don't, then we can definitely guide them through possible topics, possible areas that they could look into, things like that.
Sounds good.
But yeah, so if the judges want to maybe present their feedback or findings for the top 3 teams, as well as the best presentation award, you guys can go ahead. Drum roll, please.
I don't think we know who's revealing it.
You can do it.
Yeah,
okay.
Go for it.
All right. In first place, we have MNIST. So I think Sage, you should talk about MNIST. Give them some feedback and tell them why they're first place.
Yeah, we were really impressed with the methodology and the fact that you guys had a web app. Given that you guys were a beginner team, but also a lot of the explaining that you guys did about the model, the deliberate choices you made, especially data augmentation, the amount of rotation you guys incorporated and such. Although MNIST is so it seems cliche, the approach you guys took was very refreshing and really solid. So yeah, so congratulations, great job, guys.
All right. In second place, we have real-time mass detection. That project, I think all of us we could tell that you guys put tons of work into that. I think it had an amazing demo. And the fact that it was real-time is an achievement, given how much is going into that. So yeah, congratulations on second place. Okay, and we actually have third place and best presentation. We decided on the same project. That's the first music genre detection project. Will, you want to talk about that project?
Yeah, so in terms of presentation, like that was awesome. We could clearly hear or see your goals and the learning opportunities. And in terms of the technicalities of the project, we loved how you went above and beyond and kind of looked for your own data set, extracted features, and we thought that was really amazing. So props to you guys.
Thank you.
Thanks.
Yeah, so all teams will be contacted via Discord with a gift card to anywhere of your choice. We were thinking like Instacart, Uber Eats, and Starbucks, and they'll all be sent digitally. But yeah, congrats guys. That concludes our first semester projects showcase. If you guys have any questions, feel free to reach out, but otherwise, have a good day.
Thank you.
Thanks everyone for coming.
Good job, guys.
Thank you.
Thanks, everyone.
Thanks.
Great job, everybody. Have a good remainder of Sunday.